or you may not need to zoom in if you just want to watch the video later. Like if you're sick, you may not be able to come to class, right? So that's the thing is, it's not the expectation that if you're sick that you zoom into class, and it's not the expectation that when we switch to hybrid that you guys are necessarily working all day long at home. Like expectations are going to shift a little bit, but yeah, if you're sick, you're sick. So it's not expected that you zoom into class. So last week, we talked about all these things. These were probably the most difficult problems that we were getting to right before we left, of thinking about if this equals 0. Can anyone remember kind of, I don't like calling it a trick, but can anyone remember what I was saying about how to turn 2x plus 4 into our x of negative 4 over 2? Alina? Darn it. If I waited longer, I could have called on Kaylin.
I'm not really sure.
Ah, you raised your hand.
Well, I did, and then I put it down.
All right, we'll throw it to Kaylin. Kaylin, how do I go from here to here or from here to there? Help us out.
You, make the 4 opposite, and then divide it by the coefficient.
Yeah, so if you need to make that note, and I'm going to write in a thinner, like a thinner pen right now, what we were doing there to go from this to, well, really here first, and then we ended up there simplified, was the opposite of the constant divided by the coefficient of x, or of whatever we're using, but it's almost always x. So we said opposite of the constant divided by the coefficient. Hey, Amar, are you still here? You just turned your camera off because of internet, which is fine if that's the case. Like
that's what happened.
Okay, you're good. You're totally fine. I just wanted to make sure that you were still here. So opposite of the constant divided by coefficient. And then we came over here, and this one has the fraction in front of it, which makes it seem a bit scarier. But we can still actually, for the zeros, do opposite of the constant divided by the coefficient, because what does the fraction in front change in our parabola? We had made it to this point at the end of class. And actually, did we get a third value? I don't know that we did. Oh, yeah, we did. So this was right at the end of class, right? But we said if our zeros are 1 and negative 7, maybe we didn't actually put this on the graph. I think those were, I got negative 7 there. Oh, did I just write this down? Oh, no, okay. I had to remember all the work that we did. Hopefully your guys' brains are working and you're not just like passively looking. These were our zeros. Here's what screwed me up. I didn't put the other 0 very dark because it's positive 1, and this is also positive 1. So I should write another 1 here to see it as one of my peach-colored function zeros. Then we found the middle of our zeros, which we figured out we have to go a distance of 4. So going a distance of 4 got us to negative 3 for our x value. And then we found our y value of negative 4, and we went 1, 2, 3, 4. So my parabola actually opens upward, in this case, with a minimum of negative 3, negative 4. Do we remember that from Tuesday, or do we have questions on that? Because I'm ready with a whole new graph page to like dive into other problems. Any questions before we move on? By the way, guys, my recording will never record your voice. I've got the setting set up that it does not record my computer audio, and you guys are, of course, coming through my computer audio. So no worries. It will not record anything you say. Ooh, maybe I can get some sponsorship on my YouTube. This math lesson is brought to you by Belvita Breakfast. Maybe I can... No, is that not how it works on YouTube? I just can flash my snack and get somebody to pay me money. Come on, guys. I'm trying to make things interesting.
Didn't you get copy striked of this thing?
What'd you say? Oh, copyright?
Didn't you get copy striked?
I don't know. I think they really just got some free advertising. Middle school teachers eating Belvita snacks. All right, let's try a new one. I got to figure out where that screen went, though. I had work pulled up. -6. So, by the way, guys, I would make one page ready to graph on and another page to write your work on. So, I don't know why it keeps starting with a lowercase letter. Factored form, quadratics, really. And today is the 24th. And then my other page will be for graphing them. So our first function, we're going to call g of x. And we're going to make it -6 times x minus 2 times x. Can anyone tell me anything about the behavior of this function just based off what we see written there for g of x? Anything? Kaylin.
I think one of the x-intercepts should be the origin.
Ah, why? I agree with you.
Well, if you think about it, the x could be set as like x plus or minus 0, and then the opposite of the constant, and then divided by the coefficient of x, but anything as 0 on top means equals 0.
Yeah. So, Kaylin, you explained it exactly how I would. We can look at x as being x plus or minus 0, right? This, some of you will be like, well, that's dumb. Why would we write that like that? That's unnecessary. But this is how we need to think, right? And we're setting that equal to 0 because what if this is 0 product property, right? What if I want to make this whole thing 0? One of these pieces needs to become 0. So exactly what Kaylin said, if we took opposite of the coefficient divided by, opposite of the constant divided by the coefficient, excuse me, that'll be 0 over 1 actually, or -0 over 1, doesn't matter, is equal to 0. Or we could do the algebra. It doesn't matter how we solve this. We get x is 0. So one of our zeros is the origin. And we know we're finding the zeros, so y is also 0 there. Because remember, this is our y value, or our output, g of x. We made the output g of x. We set one of the factors equal to 0. We know x is 0, y is 0. So really, this is a point, 0, 0. If you'd like to write the point to remind yourself. So then, no, wait, so the -6 doesn't do anything? Not yet, right? The -6 does not matter yet. Somebody else, not Kaylin, tell me what the 0 is from this factor. Or just on mute, anybody?
2.
Yeah, 2, because if we did x minus 2 equals 0, then we would add 2 to both sides and x equals 2. And again, that was when we made y 0. So we get 2, 0 from there. All right, so I'm going to make these in my kind of metallic-y looking blue, I guess. We had 0, 0 to this point, and we have 2, 0. Okay, this point. Again, I'm assuming a 1-to-1 graph scale here. I maybe shouldn't have done that. You can make your graph have a different scale if you want, but I'm going to go ahead and indicate my 1-to-1 graph scale. Now, that helps me a little bit. I've got 2 points, but where do I go from here? Avi?
Find the center.
Yeah, find the center. Sorry, go ahead.
I was just going to say find the center of the parabola.
So what is it here?
1.
Yeah, the center, or that like max or minimum. We don't know yet what it's going to be, but the center is going to be our maximum or minimum. We know it's at an x value of 1 because directly between 0 and 2 is 1. Now, okay, so we found the x value of the center. What do we have to do now? Alina? Yep, we got to solve for, we got to solve for the y value. G of x. So what's that S word that we're really doing here? Instead of saying plug in, if we use the right math word. Yeah, substitution. We're substituting 1 in. Sorry, that's a G. It doesn't really look like it very much of a G. So G of x equals, well, I got to solve this now. So negative 6, 1 minus 2 is negative 1. Okay, negative times positive. Our answer is going to be positive, so I'm just not going to write anything down. 6 times 1 times 1, 6, right? Any issues? Did I make any mistakes? So our point now, since that's our g of x, or our y, our point from there is 1, 6. So 1, double checking my counting. So I'm going to draw this in my pen just so it's not so heavy. So, wow, this parabola is kind of hard to draw because it's so small. Okay, that's interesting. Last week when we had 1/4 multiplied by our parabola, or not last week, on Tuesday, we had like a really wide parabola, kind of easy to draw. The purple came from just our standard, like negative x squared minus 5x plus 6, right? We found these zeros of negative 6 and 1. We found that middle. So this was still kind of pretty wide. Looks like normal for our parabolas, right? My purple is still pretty normally shaped. This shouldn't do that. That's just my error. Can anyone make like a conjecture, which a conjecture is like an educated guess of what we think caused our parabola to look like this? Someone I haven't heard from maybe, or Kaylin. Yeah, Kaylin just tried to unmute. Or Avi.
Does it get steeper?
What do you mean by steeper? Because the problem is, if we talk about slope, slope is for lines, right? And this is kind of a line, but it's kind of a curve, right? And if we zoomed way in right up here, there is a point where our slope is flat, right? There's like a very tiny moment where we have no slope. Because if I went from, let's say, this point to this point, there's no quote-unquote slope if I'm comparing maybe the input of 1/2 and 1 1/2, right? So if x was 1/2 or x was 1 1/2. So I agree with you, but we need a different word. Steeper doesn't really work. And why, right? Why did this become steeper? Anybody else? Conjecture? Guesses? Theories? Well, theories are proven. Avi? Theorems are proven, sorry. Yeah, you're right. This negative 6 is the part that has caused this to happen. So when we have, you guys get robot calls? Every day I get robot calls that look like they're from my hometown. When this leading coefficient is greater than the absolute value of 1. Hey, Aaron, are you with me? Because you got a lot of light changing on your face, which makes it look like you're doing something else. Because if you're just watching me, there shouldn't be a lot of light changing on your face. So please make sure that you're with me. So this negative 6, that leading coefficient, if that value is greater than positive 1 or less than negative 1, right? So if we talk absolute value, if the absolute value of that is bigger than 1, we get tighter, right? So steeper is one way that we can talk about it, but it pulls our zeros, like it pulls our graph behavior in. Or another way that we can talk about it is without that negative 6. Do me a favor. Let's play the what if game. What if that negative 6 wasn't there? And we had x minus 2 times x. So let's say h of x. I'm going to switch to a Sharpie because I don't like writing in highlighter. Well, we should actually kind of be able to... Well, our zeros are the same, right? Wouldn't our zeros still be 2 and 0 because we said this -6 didn't impact our zeros? So if our zeros are the same, what's going to be different? Alina, I might start just having to randomly call on people because otherwise Alina's always got her hand up. But you're good, Alina. What's different here? What will be different?
Well, first off, it's gonna be like flipped. So, wait, no, it's gonna open. I think it's called open up, right?
Ah, you're bringing in some vocab. What you are talking about, and everyone needs to write this word down, is called concave. Whether it's concave up or concave down. So I'm going to make this part of your homework. What makes a graph concave up or what makes it concave down? That is one of our next new vocab words that we're going to start using. So as we investigate parabolas, pay attention to when you see that word and whether this would be concave up or concave down. So the question is, do the arrows pointing down make it concave down, or does this part being up make it concave up? And we know that our natural parabola, our parent function of x squared, is up, right? It's it's pointing upward. So, and if I just sketch that, guys, let's go ahead and sketch the parent function on here just so we have it. So I'm going to do it in pencil, but 1 squared is 1, 2 squared is 4, 3 squared, 5, 6, 7, 8, 9, and we can reflect these points. Well, we can do 16, probably 9, 10, 11, 12, 13, 14, 15, 16. Remember, our parent function that everything derives from, all of our quadratics and parabolas derive from, is this behavior. And that pencil graph is our parent function of y equals x squared. So I just did it in pencil because I don't want it to be too dark on my paper. So 1 squared is 1. 2 squared is 4, right? 3 squared is 9. 4 squared is 16. It's just good to remember our parent function. So that's our natural x squared, what we call the parent function. But yeah, so we're right. That -6 has flipped our function, right? It pointed it down, and it's also made it tighter or steeper, as you guys said. But back to this question. If I didn't have the -6 out front, well, 1 plugged in here, 1 minus 2, the -1 times 1, we'd get 1, -1 for my middle point. So if we went back to our graph and tried to graph our middle point, 1, -1, it looks like our orange behavior is going to go up. Because here is why I said 3 points is a minimum. Can I tell what this parabola, my orange, is going to do with just these 3 points? Not really. Right? Like, these zeros and that minimum were a little further away, so it was a little easier to tell with the blue graph. But with the orange graph we're working with, 3 points is not enough. So let's get more points. Choose values outside of these. And I hate how I wrote these. These I really kind of should have switched around. But if I go outside of the 2, I'm not just going to go to 3. Let's say 4, right? So if x is 4, let's solve it like that. And let's do another point for if x is, well, we've got a 0. Well, let's go 2 beyond that. Let's do an x of -2 as well. So 4 minus 2 be 2 times 4, 8? Negative 2. Negative 4. Oh, that makes sense because we're going to reflect. So, guys, as we start to graph parabolas, we'll start to see we have reflections. 1, 2, 3. I could actually just jump up here and know that that's going there. And that's going there. No, negative 2. 1, 2. It's there. My bad. Ignore that point because I needed negative 2. Wait, that's not right. Is this negative 8? Oh, come on, guys. Come on, guys. I do this on purpose sometimes. If I reflect it, it's positive 8, but we did my multiplication wrong. By we did, I mean I did. I did this on purpose to see if anyone would catch me writing different numbers. Sorry, and it might just be that it's out of the screen for you to be able to see. When we go outward from our points that we have, the behavior should stay the same. So if you get 1 as positive and 1 as negative, this is not right. I need to have an alarm go off in my head and say, wait a minute, one of these is wrong. And if I check my math, negative 2 minus 2, negative 4 times negative 2, this should be positive 8. So my point is correct over here, but be careful. As you're doing the math, just tell yourself the behavior should stay the same. If I'm going upward, my other side's going upward. So now we could sketch that. We can connect those, but then these have to be connected with kind of a low curve, and we can start to see the parabola. So if we want to make a note on this page, just so we have it written down, our orange parabola was x minus 2 times x, or if we actually distribute that out, it's x squared minus 2x. And if we wanted to write it, it's plus 0, right? That's why our y-intercept is 0. Our blue graph on this page came from negative 6 times x minus 2 times x, or negative 6 times x squared minus 2x, and we could write plus 0 if we wanted. Or we could write this as negative 6x squared plus 12x if we wanted to. Plus or minus 0, we don't really need to. Any questions on what we have written on here so far? So I am picking these problems based off what we have struggled on as we do this practice on our own. I want you guys to graph, and then we'll check your graphs. I'm going to write this in red, although I'm going to preface that with I don't love red. It seems like an aggressive color, but I'm just using red because it's a color I haven't used yet. For quantity, x plus 6, quantity, x plus 4. Graph that on your own. So you're going to want to find the zeros, find the center, right, which actually we call the vertex. So if you want to start calling it the vertex, we call it the vertex. And then probably find a couple more points. Now this is kind of a pet peeve of mine, but I like to list my lowest 0 first. Can anyone that I haven't talked with yet today help us out with what are our zeros here? Like Margaret or Aaron or Katie Ann or Amar. Yeah, just unmute. If you want to help, just unmute and jump in. Yep, the zeros, the x value for the zeros. Sweet, throw them at me. And negative what?
4.
Ah. So we could, if you guys want, you're allowed to just say x is negative 6, comma 4. This is not a point. It's a list. Right? So you could write the points, or you could write x as negative 6, 4, because we know that y is 0, because we called it the zeros. So I know on the last two problems, I've written out the points, but I just wanted to tell you the notation piece. You're allowed to just say x is negative 6 and 4.
4 should be negative.
Thank you. I had actually just caught that because I saw your hand up, and I was like, why? What does Alina want to tell me? She wants to tell me I made a mistake. So then the vertex is directly between them, which, okay, well, that's not that tough here. What's directly between negative 6 and negative 4? Anybody? Unmute.
Negative 5.
There we go. You don't have to raise your hand. I keep saying we're a small class. So I know that the x equals negative 5, but then I do have to figure out the y. So once I know the x, I plug it in and I solve for y. Guys, I would always write this work out. You are asking to make a mistake if you don't write this work out. So negative 5 plus 6, negative 5 plus 4, negative 5 plus 6 is 1, negative 5 plus 4, negative 1. My answer will be negative 4 times 1 times negative 1. Negative 4? Crap. Trying to write my point backwards. Negative 5. Negative 4. Is this right? Can somebody give me like at least a head nod? Did I make any math mistakes? Okay, sweet. Guys, I make math mistakes. It does happen. Like, not even on purpose when I'm trying to see if you guys are paying attention. So that's why, seriously, when I ask you, like, can somebody verify? Please don't just say yes. If you've solved the math and checked it on your own, that's when I want your verification. If you haven't solved the math, don't just say yes. Teachers aren't always right? We're humans too. So please don't just say yes. If we go to put these points on our graph, 1, 2, 3, 4, 5, 6. So there's our zeros. Right, negative 5 is right between them, negative 4. I've got some pretty good idea. Sorry, you couldn't see that. I've got a pretty good idea of what the parabola is going to look like just from these 3 points. But 3 points is not enough. Right? If there's a computer system doing the rest of it for you, that's fine. But guys, here's my like out loud warning. I will ask you to manually graph parabolas on paper when you come back to Phoenix next week. So, oh, by the way, to my like blue versus green conversation, assessments we'll take here. Like you would come to class and take the paper assessment. Assessments we will take at school on your in-school day. So I never like to stick with just 3 points. I like to find at least 2 more. So I'm going to go outside of my zeros, and I like to go, well, it depends. This parabola looks like it's going to be steep. I would not make a big jump. I would just go to the next points. So we're going to say when x is negative 7, right, to push past my negative 6, and when x is negative 3. So my other points, I'm going to choose x is negative 7 and x is negative 3, and then I'm going to find those points. For negative 7, if we write the workout, By the way, you guys can also just like not look at my screen when you're doing the math. If you want the challenge, I will try to more and more stop saying numbers so you can look up for verification, but I'll try to be quiet while we're writing the workout. And then -3. These should be the same. If I'm continuing like off of my center point, if I'm coming out from my center, they should be the same. So I got that -7 needs to go up to 12. So instead of just guessing what happens after these points, now I can actually connect Now this is tough, but when we're drawing parabolas, what I just did is what we want to try to avoid. This now looks like a straight line. Try to avoid that. It is a continuous curve. So my right side of my parabola here looks a lot better than my left side because this is like a continuous curve and it has some slope. This left side looks like it goes straight up. It really doesn't. But we want to write down that parabola so we've got kind of our reference sheet. So this parabola would be the 4 times x plus 6. And guys, if you don't have a set of colored pencils or colored pens, try to get one before you come to school next week, if possible. Otherwise, I can share some, but then we have to wipe everything off. I take all of my math notes using colors. So like now that we've got all of these parabolas on the same page, we really want some color organization to know this matches this matches, you guys get it. So if we if we went ahead and multiplied this out, can everyone do the FOIL for me of x plus 6 and x plus 4? Go ahead and do that FOIL. I'm going to come back to this page and do that FOIL. I'm intentionally pulling this down where you guys can't see it. So when I FOIL it, I got x squared, 4x, 6x, and 24, and I know we're about out of time. And so wait, then my y-intercept is going to be 24? That doesn't seem like it's going to, my y-axis is way over here. That's already at 12. Can anyone help me understand? I don't think my y-intercept is 24, but that's what it looks like right here. Somebody unmute and just tell me what I need to do. L?
Multiply it by the 4. Yeah.
Oh, yeah. This 4 matters now, right? The 4 doesn't matter for our zeros. That multiplier out front doesn't impact our zeros, but it impacts everything else. So this y equals is actually 4x squared plus 40x plus,
96?
Thank you. I love this math class because I know if I hesitate long enough, one of you will just shout the answer out because it's like, I know who you are, and I know how your brains work. So I often just wait for you guys to give me the answers. So our y-intercept here would actually be 96. So guys, what we're going to continue investigating and discussing and figuring things out is if you were given this right, we talked, I forget if it was Tuesday or last week, about the situations where we factor out a common factor. Is everyone good on writing this down? Which actually, guys, let's come back to this page. Let's write down that form of it also. So 4x squared plus 40x, just so we have some reference parabolas, plus 96. So we can refer back to our pages and see like the different behaviors. So I think what we figured out today is the negative leading coefficient flips our parabola, right? Any leading coefficient that it has an absolute value greater than 1 tightens our parabola, and the further that number is away from 0, like if we compare the graph with the 4 as the leading coefficient versus the 6 or negative 6 as the leading coefficient, the one with the 6 is tighter, right? So if we made this like negative 10 or negative 12, it's going to keep getting closer and closer in. Can anyone tell me why? Why does, like, why would this be tighter, quote unquote, than if this was like negative 3? What is the function telling us? Like, negative 6 times x minus 2 times x, why do we do that? Why are we doing this math? Like, when we plug in a value for x, what are we getting? Anybody, you can just unmute. I'm just trying to have a little conversation to wrap up class.
You get the y coordinate for the vertex.
Which is what? Give me another name for the y coordinate. What we're doing with all this parabolic work is we're saying that the output of the function, right, the output, whatever we call it, y or g of x or whatever, is something times our input plus or minus something else, probably times another, sorry, I'm just going to make this x because I already started making the x. So another input plus or minus something else, this negative 6, or this 4, or really this 1, remember there's a 1 here, we can always assume 1, that is multiplying to impact the output. And we're gonna pick this up next week. But guys, these two binomials will together become a trinomial, right? These will become ax squared plus bx plus c. And still, we're going to then be told, okay, to get your output, multiply whatever you got by this other number outside. And sorry that my y-axis is through the middle of all this. That's why the leading coefficient has such an impact. It grabs the output value and stretches it higher or compresses it lower, closer to the x-axis. So I know I'm out of time. That's the last thing I really wanted to say, is the reason these leading coefficients are impacting our graphs like they do is it's impacting every output value. All of the math that happens to the input happens in here, and then the last thing that happens is the multiplication by that leading coefficient. Unless you have any questions that you'd like to hang out and ask, I appreciate you guys coming to class today, and next week the whole game will change, right? So I will see a lot of you guys here in person on Tuesday. So thank you guys. Thank you guys very much. Have a wonderful day. What's your question? Hold on, I'm going to stop share, and I'm going to stop recording.